All right. Hello, everyone. Thank you for joining for one more session of our developer course. For those of you who are new to our series, my name is Juliette, and we've been building this developer series every 2 weeks. We're basically trying to just teach some code during this pandemic to those of you who are interested. And the topic of today will be an introduction to programming through a language called JavaScript. So for those of you who this is your first time, don't worry. There's no previous knowledge required. Especially today, we're going to be seeing some different concepts than what we've been seeing in our previous courses. So feel free to ask some questions, raise your hands through the chat, and I'll make sure to read those every so often to keep track of what you guys are thinking. So, without further ado, let's begin. So, to give a little bit of a recap of what we've been doing up until now, we first covered some HTML concepts, and HTML is basically a front-end language, which means hypertext markup language, and all that this is sort of the columns of what we'll be building for our design. So if we think of it in terms of a house, we can think of HTML as being those big structures that are holding the entire house together, the ceiling that puts it all together. But if it's just, it's really important so that the house keeps steady. But if you just look at it like that, no one really wants to live there, right? So HTML is crucial as it's sort of those building blocks for our site. But really, it's still not nice until we add some CSS to it. And CSS is sort of that part of the design which makes our sites look beautiful and makes them interactive. It makes them add some colors, some fun, some cool icons all over, images. And just with HTML and CSS, you can definitely build a website. But, and this is where it gets tricky and what we'll be learning today, is that whenever you add on that JavaScript, that's that extra kick of the Internet of Things in your house, the smart TV, the control that turns the curtains on and off. So it's sort of those animations, the drag and drop, the drop downs, the moving around, the changing colors, and those things that we've become more and more used to seeing around the web these days. That are not necessarily needed for a website, but are definitely expected as we browse and browse more in 2020. So what we'll do today is that I'll take you through a bit of an overview of the tools that basically every programming language will have. And we'll use JavaScript as the way to teach these things, because in our next class, we'll be seeing how we can use JavaScript with HTML and CSS and add some of those funky animations to our site. So if you think of any language, just let's think of English, for example, we think of English as having some sort of a tool set, right? So we have maybe some verbs, we have some nouns, some adjectives, some adverbs, and these are all of the tools that are needed in order for us to speak English. And so in programming, we have a very similar thing in which we have our data types, we have our variables, we have loops, conditionals, functions, and these are sort of those components that make us be able to speak a programming language. So in order to take a bit of a holistic look, let's go through each of them and I'll show you exactly what I mean. So the first one we'll be seeing is data types. And data types is sort of the building blocks that will then allow us to keep on moving forward. So the best way to show you will be to do some live coding. And just so you know, this is an integrated code environment. Well, I'll be using my text editor on top and then my console on the bottom. So what this allows me to do is to run some code. So I'll create a file called datatypes.js, because JS stands for JavaScript. And then we'll see that whatever I write in here, I can just run it in my terminal and it'll display it. So for example, if I want to say, please, for my console, log me a 9, and then I'll go in here and I have to write node because that's what will compile my JavaScript file and run my program. So I can write node and call them that specific file, which is data types. And don't worry, you don't need to know all this, but it's just so that you see that whatever I write up here, whenever I write node and write the file of my name, I'll immediately be able to see it. So let's do some more funky stuff rather than just do a console log 9. But taking that example, we have numbers as one of our primary data types. So in programming, numbers are actually called integers. And I can do with an integer anything that I can usually do with a number. So I can do 9 plus 5. I can do 9 minus 5. I can do 9 multiplied by 5. And I can do 9 divided by 5. And if I write again, node data types, and run my file, what I'll be able to see is that my compiler is actually running all those calculations and then displaying it for me, thanks to me writing console log on, before it. Now, what other data types can you think of that we're usually using as we're going through the internet? You know, if I open up a Google Docs file, what usually are the types of data that we use? And let me see if I could just get the chat up in my screen so that I can see what you guys are writing. Yeah, so text is definitely a good one. So if I write text in programming, those are actually called strings. So I can say console log hello developer peeps. And then when I run my program, I'll be able to see the string that I added. And the computer knows that this is a string merely by me writing those 2 quotes around it. Now, these can be double quotes. These can also be single quotes. And we could even write the backticks. Now, backticks are special because even though if I just run my program like that, it'll run it exactly the way it run my other 2 quotes. Our backticks allow us to do special magic. And what is this special magic? It means that if I want to write how many developer tips we have, I can say, I will write a money sign, 2 curly brackets, and then it can make some calculation inside of those curly brackets. So I can say 9 plus 10. And when I run my file, it'll actually display me whatever that calculation is inside of it. So if I were to write that inside of the regular, the other brackets that I mentioned before, sorry, the other quotes that I mentioned before, if I were to say the same thing, but write 9 plus 10 and run my program again, we'll see that it just actually writes it down. So that's where the backticks are pretty powerful. Especially when we need to add some stuff inside of it. Now, aside from text, we also have lists, right? So lists are actually called arrays in programming. And arrays are nothing more than a list of items. So we wrap them up in square brackets, and I can have a list of numbers. I can have a list of fruits. So I can say I have apple, I have a pear, I have a banana, and we could also even mix them up together. So I have a pear, I have an apple, a 2, and a banana, and then I could also even have lists inside of lists. So I can have a list of numbers as one of the items inside of my list. And then when I print all of that together, I will see that everything works, okay? So an array is just a list of any of these data types that we're putting together. And realistically, we don't usually ever put different types of data inside of lists because we want to keep them as clean as possible. This will usually turn into bugs. But I just did it so that I could show you that we could put whatever we want inside of these lists. Then another cool data type that we have, and please, if I'm going too fast, if you have any questions on these, make sure to write them in the chat and I'll check them once we're done with this section. But another data type that we have are what I think of as tables. And these tables are actually called objects. So I can say to my console to please log me a human. And so this human will have a name, which is Jules. The human will have an age, which is 22. I'm not going to tell you how old I am. I know you were wondering. I'll have a nationality, which will be Panamanian. And then maybe I could even have cousins, my list of all of my cousins. And then that could be a list where I'm writing that my cousin is named Juan, another cousin is named John, because we're not that creative. And then whenever I hit to actually run my program, I'll see that I have my object of a human. And this is very powerful because then it means that it's not only just, you know, random information put together, but it actually provides some context to what I'm building and bundling up together. So I would say these are our main ones. There are a few other ones that we could touch upon. But the only other one that I want to make sure that we know, are Booleans. And Booleans is nothing more than a true or false. Okay, and this is very powerful because Booleans are what allow us to make conditions as we keep on moving through our code. So I'm just going to console log it so that you see that it'll only say true or false. But keep this in mind because as we move on forward with today's course, we'll be able to see more of these Booleans around and what they can actually do and represent. So I'll make a stop here, check if you guys have any questions. And that's funny. And if there aren't any, I will keep on moving. Questions once they're here. All good. Awesome. Okay. So that's our first key component of programming. And this is very helpful because that allows us to see different data through different lenses. But what happens if I actually want to store it somewhere? Right now it's just floating around the internet with no family or nowhere to actually be persistent and kept. So what we want to do is get a backpack. We're getting a box. So variables can be understood as merely a box. We're going to be storing information inside of it. And in JavaScript specifically, and this is not true for every programming language, but for JavaScript specifically, we have two different types of backpacks. The first one is let, which basically lets you change it. So whenever you write let and the variable name, it's a variable that whose value can be changed as the program moves forward. And const is a constant whose value cannot be changed. And we'll see what that means in a second. So the first thing I will do is that I had a cute emoji there. That's unfortunate. So here we have, the first thing we have is that we declare the variable with a name. So I have a constant whose variable name is first name. And then, oh man, that was supposed to be a queen. Okay, so, and then we have the value of first name, which is Jules. And the interesting thing here of variables is that we really want to be reading them from the left to the right. So rather than thinking of the variable as being first name, we want to make sure that we know what we're putting inside of our backpack, whose name is first name. And this will be important because as we start using variables, we want to make sure that we really know what is inside of them. So for example, in this little piece of code in here, we have another variable called birthplace, which is Panama. And then I'll say, hey, console, please log me first name, whose value is Jules, is from birthplace, whose value is Panama. And if we run that in the console, it'll run this string in here. So we can see two things with this code snippet. Number one is that variables are merely backpacks, boxes full of information, whose value we can tap into as we call them. And then the second thing is that we can use them inside of our magic brackets and actually get its value displayed as we want it. So let's have some fun with that. Let's build another file called variables, and we'll have a constant named park. Now let's say, oh, sorry, I missed the name. No, let's have a variable called park, and let's have this be Central Park. Okay, now that is very cool. I can just now console log my variable park. And if I go into my terminal and actually run my file, so now you see, instead of running data types, I'm going to be running variables.js. And when I run that, I get Central Park. Cool. So it's actually logging whatever I write inside of it. What is park? Park is Central Park. But now, let's say I want to change the value of park to Parque Omar, because I'm from Panama and I want to get Panamanian in my code. Now, when I write console log again and run my program, I get an error. And the error is saying that I already assigned a constant variable and that value cannot be changed. So this is where our let variables become useful, because now if I run my program again, I get both. So this is the big difference between one or the other. And as we move forward with our next concept, we'll be able to see how this is useful. Any questions until here? Cool, we carry on. So the next thing that we're gonna see are conditionals. And from what we've been seeing throughout our few examples, we can see that our code has been having a certain flow, right? So in this, variables file, we see that when I log console log park, in this moment, park is Central Park. So that is being logged first. And then park is Parque Omar, and that is being logged second. So the flow of the program is to just go from top to bottom. Straight, and whatever is happening, it'll log it, carry on, and moving forward. Now with conditionals, we get to change that flow, right? So now it's not only going to be going from top to bottom, but we can actually take some deviations throughout the way. So let's take this as an example. So I'm going to say, if my nationality is Panamanian, then I'll greet me with the classic Panamanian word, queso pa. Otherwise, if my nationality is French, then I'll greet them with bonjour. Otherwise, just say English, hello, because usually people will speak English. And so what we see here is that unless my nationality is Panamanian, I will never get queso pa, right? All of the other ones will never be executed. So even though they're below in the flow, these will never run, because once this condition is true, then this is what will get returned. So what we're doing is that we're changing the flow. I have a variable that's my nationality, and then I ask, okay, is nationality Panamanian? Is this true? If this is true, display queso pa. Otherwise, is my nationality French? If that's true, display bonjour. Otherwise, say hello. So if we see that in actual code, we'll see what is happening. So the first thing that we always need to do is set up the variables that we're going to be going inside of that condition. So let's have a constant that is nationality. And in this case, let's say I am British. And then I'll run my conditional saying if nationality, and check this triple equal sign, okay? Then there's a big difference here. We can see that one equal sign is defining the value of this variable. So I'm just stating that whenever I see nationality, I want nationality to mean British. Whereas with a triple equal sign, I'm checking whether this one is the same as this one. And we'll see how that goes in the end. So I can say, if my nationality is Panamanian, say queso pa. Otherwise, and let me just fix the indentation, because otherwise that'll bother me. Otherwise, if nationality is French, then let's just say bonjour to my fellow French mates. Otherwise, then let's just display a classic hello. Now, according to my program, and if I clear here, if I run my conditionals file, I see hello. So what's happening is that because nationality is British, it's going into my first condition and it's saying, hey, is British the same as Panamanian? Nope, this is false. Carry on to the next one. Is British the same as French? False. Okay, then just go into the else and display hello. So this is the first example of where we're seeing how we're going to be changing the flow throughout our programs, and we'll keep on seeing this throughout the rest of the examples. Any questions up until this moment? Nope. All clear? Cool. So then let's move on to loops. So loops, I think, is a really cool one, or at least one that I liked when I first learned, because I guess I personally hadn't really put into perspective the amount of loops we do in our daily life. So, you know, it can be as massive as just like a regular day. I wake up, I eat breakfast, I go to work, I go to bed, and then the next day comes and I eat breakfast and I go to work and I sleep, and and that's just a regular loop of life that only ends, I guess, when I die or retire. But it can be actually something even smaller of just eating, right? I'm having a plate of food and I'll eat until I'm either full or I run out of food on my plate, right? So these are the two conditions that will make me stop eating, that will make me stop the loop of putting food onto my mouth. And so what we're going to do with code is exactly the same thing, right? So I'm going to have an age variable, which right now will be 1. And we can see that this is a variable that I can actually change. And then I'll say, while this condition is true, so while age is smaller than 18, then please perform this loop. And this loop will say, hey, you are 1 years old. You can't vote. 1 year passes. Okay, I go inside while, and now you see age is 2. So if 2 is smaller than 18, hey, you are 2 years old, you can't vote. 1 year passes. Now age is 3. And we'll keep on doing that until this condition is fulfilled. So until I am 19 years of age. And at that point, then I'll say, hey, you're finally 18, you're allowed to vote. So let's see what happens when we actually create that file. Let's see that fun in action. So I create a variable called age, which is going to start at age 1, right? Because, well, I mean, I guess we could do 0 months, but that'll just get messy. So I'm going to say while age is smaller than 18, I'll tell you that you are age years old, you're too young to make decisions for our country, man. Okay? And then once I log that, I gotta make sure that a year passes, because otherwise my loop will keep going on forever, right? I will never be 18 if a year is not changing in the variable age. So I gotta make sure that age is age plus 1. And then I'm gonna, once that loop is done, then I'll write that you're finally 18, now you can vote. Now, when I run that file, check out what happens. It literally goes in a loop forever until that condition is being fulfilled. And only when that condition is true, then it gets out of that flow and carries on with my program. So you see here, we are also changing the flow, because we're saying only until that condition is met can we really get out of that endless cycle and perform a different, print out a different solution. So you see how here it's very important that our variable is able to change, because now if the age is changing every year, then that value needs to be a value that can be changed throughout time. Any questions on loops? And Ana Margarita will send the recording soon. We have those on YouTube. I think Vane is here. Vane, if you could send that in, that would be very cool.
We'll send it.
Awesome, thanks. Cool. So that is loops. And now we'll move over to the last bit of what we'll see today, which are functions. Now, functions are usually what people think of when they think of algorithms, right? And you can imagine as functions as being sort of the verbs of the programming languages. So they're basically those actions that we call on that can be performed through the noun, so through the objects, and we can call them whenever we need them to perform a specific action. Now, just like any word in our dictionary, functions will always have two different steps. So we first have to actually define them. So, right, sleeping is laying in bed, closing your eyes, relaxing on the world. That's our definition. But only until we actually say the word, only until we use it, does that word actually have a meaning. So that's where our functional call comes in. So it's not enough to just define it. We actually need to call it and use it for that word to mean something. Otherwise, it's just grabbing some dust inside of a dictionary that no one's really using. So having that concept in mind, when we're defining our functions, we usually can think of them as having three key parts. So we first have the input that's going to be going into our functions. This could be nothing, or this could be tons of data we've gathered from our database or from wherever we're inputting. It could just be plain text as well, hard-coded. This is information that we're going to be putting inside of our algorithm. Our algorithm, which is our actual function definition, is going to be running some crazy stuff, using that information to add, subtract, delete, read, whatever it is that we want to do with it. And then once that crazy thing happened, then the algorithm would output a return. So let's see that in an actual code snippet. So we have a function, which I'm calling a COVID reminder, right? This is the name of my function. And then I'm going to pass it some input, which will be the name of the person that I'm reminding of COVID, as if anyone could really forget these days. And I'm going to say, so this function, whenever I call it, is going to return the name and say, hey, Jules, just wear your mask. And so still, if I just have that function defined, I'm still not doing anything with it. It means nothing. It's just stored in a dictionary somewhere. But until I call it and I say, hey, console log, please print me whatever this function returns, then that's when I actually see, hey, Jules, wear your mask. And we see here that what my function is doing when I call it is that whatever information I pass it, in this case, the string Jules, is going to be sort of like a hallway onto what name is. So we can see it as sort of a hallway in which we're passing information. Whatever I put inside when I'm actually calling my function is the data that will then go inside of whatever's in parentheses and replace what that value holds inside of my function definition. So that when it actually returns the output, I see, hey, Jules, wear your mask. So let's run an example so that becomes a bit clearer. So this is functions, and I will create a function that says happy birthday, and I'll do happy birthday for Jules, and I'll pass in the amount of years that she has. Oh, sorry. Oops, I did that wrong. So I'll pass in for a given name, and I'll pass in the amount of years old that she has. And I'm gonna return a simple string that says name, happy years of age. Okay? So if I just save that and run my file now, I have nothing. Now, this is very interesting, and this is a concept, or at least it's interesting to me, I don't know. This is a concept that really blew my mind when I first started coding, because I was like, what's the difference between a return and a console log? Like, why do I need both? Why can't I just write console log here, right? Because at the end, that's what I wanted to do. Now, the reason for that is because we're holding two different things separate. We're having a function that returns a specific output, but until we actually display it, we're not seeing it. So you can understand the return as sort of being a secret that is kept in the program that we might want to use later, but we don't necessarily need the user to see every single operation we're doing, right? For example, if we're having a car, we want to be able for the user to see, to tap the start button, but we don't want them to see how the engine is running, what's happening with the motor, how the oil is going through it. That's technically irrelevant for us. The user you only want them to see a start button, and then you want all of these things to execute on the back. So it'll be sort of a similar thing where we want our functions to return something, but only until we say that we want to display them is when our program actually displays that. Now, check out this output. So we can see that what our function is doing is that our program is first defining this, storing that in the dictionary, and then the moment I call it or I use the function, that's when it's going to go, hey, use that word. What does that word mean exactly? Oh, it means this. But what is this? I need a name. What is name? Name is the first element that I'm passing inside of my parameters. These are called parameters. Sorry, yeah, arguments. So I'm grabbing this, it's going in through the name hallway, and then it's going to be using them inside of my string. And then it's going to be doing the same thing with the second element, going inside of my years hallway, and then being able to display it in years. So this is what I meant when I was showing you that graph before, that our functions are really dependent upon whatever information you pass it. That's what the information that it's going to be having in order to display the given output that you want. Okay, that was a lot. Questions until here? Nothing? All clear? Cool. Okay, so having that said, that was all fun and games, but now let's mix it together, right? Now we have all of these components together. Let's build something cool where we can use all of this together and see a program that we can actually come up with. So in our mix party, what we're gonna have is an actual party where we're gonna get a human, who is gonna be me at that moment, my 20-year-old self. And I'm going to say that my name is Jules, my age is 20, and I am Panamanian, right? So this is the human that I'm going to be passing whenever I'm calling my function. But what is this function? What does party mean? Well, let's go into my definition. So party is a function that takes in a human. In this case, oh, sorry, this is a typo. That was meant to be Jules. But this is a function that is going to take in a human, and I'm going to say, if the age of this human, which in this case is 20, if the age of this human is bigger or equal than 18, then I can party the night away. Otherwise, I'm creating a variable that's going to be years until allowed, which is going to be 18 minus whatever my age is. And I know that in this case, age is going to be smaller than 18, right? And I'll say, you'll still have years until allowed, years to go. So let's try our party function out in our mix party. So I'm going to create a function that is going to be called, let's keep to the party mode. That is going to be called party, and it's going to hold a human. And I will say if human.age is bigger or equal than 18, so this is the condition that needs to be true in order for this to be returned, I'm gonna say human.name, you can dance and drink wine. Otherwise, then I wanna calculate how many years they still have until they're actually 18. So I will declare a variable, which is years until allowed to drink wine. And seriously, guys, you want to keep your variables as specific as you possibly can with actual meaning. No just because this can be called X, do you want to call it X? You want to be nice to your fellow other developers who are going to be reading your code, even if that's long and annoying like what I just typed. So years until allowed to drink wine, I will say 18 minus age, and then we'll just return a string, which we'll call on the name of our human. So human.name, and I'll say you still have, and I'll call on my long named variable, years to go. Now, that is my function. If I run my program now, nothing will happen, right? And nothing is happening because this is merely the definition of my function. I still haven't used it. I created it in the dictionary, that's great, but nothing is being called. Only until I actually call it. So I call on party and I pass it my human. So let's create my human variable. And let's say Vane will be my human, who has a name, which is Vanessa, who has an age, which is, let's say, 10, and who has a nationality, which is Bolivian, and she is the human that we're gonna use. And then let's actually build another human. So I'm gonna have another human called Alexis, who's gonna have a name that is Alexis, who's gonna have an age which is 40, and who's gonna have a nationality which is Panamanian. And let's see what happens if I call my same function, but with different information inside of it. So if I run my program, error, oopsie, typo. Let's clear that up, try again. 18 minus h, yes. Okay, so check this out. So the error that it's giving me is that age is not defined. Now, why could that be happening? It's happening because there doesn't exist any variable called age, right? Whenever I want to tap into the age as a variable isn't defined anywhere in my code. What's defined is human.age. So you always want to keep in mind that whatever variables you're using are variables that have been previously established throughout your code. And so now when I run my program again, I see nothing because I haven't written my console log. And I know that this may sound repetitive as I'm going through it, but believe me, as you'll start coding, some of these concepts will get kind of blurry, and so it's always nice to sort of keep on moving through them. So now that I get my mixed party, I can see that Vanessa still has 8 years to go. Poor lady, she's only 10, whereas Alexis can actually drink some wine. And this is the real power of functions, because functions, we can use them over and over as we want through our code without having to rewrite the same thing, right? As long as I pass it the information that it needs, it'll be able to execute the definition, and I can just call it twice, 3 times, 7 times with 700 different humans, and it'll run the same thing. So this is how, for example, you know how Facebook will create these like small videos with you on your pictures, or even just say like, hey Jules, happy birthday, I know you're turning 10. And what they're doing is that they know they have some standard data of me. They have my name, they have my date of birth, they have where I'm from. And what they're doing is that they're just creating the standard function and then putting inside of it how many humans they want and then displaying that to you. And then they're using probably some conditionals, some loops, some even custom data types to be able to play with the flow of what you're seeing and create different scenarios that feel as personalized and as customizable as possible to your specific circumstance. So, any questions until there for our little mix party? So, guys, that was all for today. Hopefully that gave you a bit of an overview and some grasp of what programming is. This was ideally what we're going to be doing for our next course is that we're going to be using these concepts along with some HTML and CSS to create some fun animations in our page and see how we can actually see some stuff change dynamically through our website and the portfolio page that we were playing with before. These are concepts that, and this is just as a reference, but these are concepts that almost, I would say, all programming languages have. And so just having them on the top of your brain as you're going through websites, as you're going through web apps, as you're running through your daily digital life, they can be useful to understand why computers behave a certain way versus another. So if there are no further questions, we can stop there, and hopefully I'll see you guys on 2 Wednesdays from now. And I'll just leave it this. If you want to practice, I have left some resources in the same page as always, where you could learn and practice more JavaScript differently from the other sessions where we've been using some already pre-coded setup. What I've done here is that I've allowed you, that I've shared with you some of my favorite resources to learn some JavaScript. I would recommend to use these next 2 weeks to just practice, get more familiar with the language, so that when we come along in 2 weeks, we'll be able to really push some fun stuff forward and see how everything on your screen changes and does some crazy stuff. So having that said, hope you guys have a great evening, and I'll see you soon. Bye, guys.